Hi everyone, welcome back to the workshop, and this is part 2 of the repair and restoration of my E3631A Agilent bench power supply. If you haven't seen part 1, I'll link it down below, and we continue on with part 2. And I thought I'd kick off part 2 actually with trying to take a look at why the positive 25 volt rail just seems to be stuck at 40 volts, or jumps all over the place. It's not working like the minus 25 volt rail is. I'm not really caring about the display at this moment in time on the power supply. I would just like to get the output working. So let's take a look at that now. So here's a schematic of the final output stages of the power supply. You've got the final outputs at this side here for the positive 25 volt rail, and the final output of the minus 25 volt rail. This is the side that goes off to the banana jacks. And over here you've got the pass transistors here for both the supplies. Slightly different architecture on the positive 25 compared to the minus 25 obviously. On the minus 25 you've got an NPN transistor, and on the positive 25 you've got a PNP transistor. So the logic around the op amps and the drive transistors will all be sort of inverted, if you know what I mean. So taking a look at the control of those output transistors, in essence you've got here positive 25 volt constant voltage reference. This is the signal that comes from the DAC that basically controls the final output. And then similarly on the negative 25 volt side, here is a minus 25 volt constant voltage ref to control the minus 25 volt. So I'm going to put my multimeter on both of those there just to see what we're getting. And this is obviously the output from the DAC, which we haven't looked that closely at yet, not on camera anyway. So we're kind of bypassing that and going direct to the output stage, and we'll see what we've got there. Okay, and here we go. I'll put a bit of blue masking tape on the heatsink. It's really reflecting the light into the camera. And so R54 down there is the signal controlling the negative 25 volt side. As you can see, I've got 1.3 volts on the multimeter there, and if I just screw that right down to 0, and I'm monitoring the multimeter off camera, there's it at 0 volts. So you've more or less got 0 volts there, and I'll just wind it up and I can see the output going up, and this control voltage going up as well, and it tops out at about 2.75 volts for the 25 volt output. So that appears to be working great. So now I'll put the power supply onto the positive 25 volt output, and I'll go onto the corresponding resistor and feed on the positive 25 volt side. That should be R88, I believe. 89 I want. There, R89. I'll wind the rotary encoder right down, that's at 0 volts, and I'll wind it right up. Of course I can't get an output because it's 41 volts permanently, and you can see I'm getting minus 2.7 volts, so that's working great. So what we're seeing there is that the control voltage for the negative side, the minus 25 volt sides, seems to be working, and the corresponding control voltage for the positive 25 volt side appears to be working. Now it was mentioned that perhaps to look at the optocouplers on this power supply. There is 4 optocouplers, analog optocouplers on the main board. However, they're only used for the 6 volt channel to achieve the full isolation. The positive and 25 volt rails don't have them. This basically comes direct from the DAC effectively. There is no optocouplers. And that's why those resistors there are actually on this top side main processor board here. Right, so the next thing I want to check is the constant current reference settings. That comes from the DAC, and here it is here on the minus 25 volt rail, comes into R55, and the corresponding one on the positive 25 volt rail is here coming into R96, and they're direct from the DAC. Right, I'm on the positive 25 volt rail at the moment, and if I adjust the rotary encoder on that R96. The positive 25 volt CC ref signal, go all the way down to 0, minus 0.1, all the way up to minus 2.7, merely 2.7. So that control appears to be working. That's for the positive 25 volt rail. So now if I switch to the negative 25 volt rail and go on to R55, I believe it was, and as you can see, on the minus 25 volt rail, it's basically 0 all the way up to 2.6. So it's working just like the positive 25 volt rail is. So there we go, I've tested the reference signals. So on the positive 25 volt channel, your voltage reference is 0 to minus 2.7 volts and the current is 0 to minus 2.7 volts. On the negative 25 volt channel, the constant voltage is 0 to plus 2.7 volts and the current is 0 to positive 2.6 or 2.7 volts, thereabout. So it would appear that those signals are working great. So why is the positive 25 volt channel stuck at 40 volts output? Well, let's take a look and follow the signal in to this op amp here from the constant voltage reference signal, which we know is working. And let's take a look at this op amp here. Let's measure pins 12 and 13 and then see what pin 14 is doing. Right, so there's U26 down here, so let's measure pins 12 and 13. There's pin 12, minus 0.4 volts. Pin 13, more or less 0 volts. That can't be right. And then pin 14, with those wildly different inputs there, you're going to get the output, pin 14, yes, swung right round almost to the negative rail, minus 15.4 volts. That's not right. Now there is another signal coming in from the DAC and it's just marked A, but it's common to both channels, so we can rule that one out. And it's roughly sitting at about 0 volts on both the points there. So I think we'll turn the power off and we'll start measuring some of these resistors. Since I've already got a history of being a resistor problem on this power supply, I think we'll start measuring out these and the diodes, etc., and just see what they're sitting at. Well, here's a possible problem. Going round the resistors, R90 should be 200k. I don't think I'm getting that. Let's go down onto the board. And there it is there. Well, if I just zoom out, let's have a look at the multimeter. There we go. Go on to that resistor. That meter's okay. .7 meg. And I have actually tried tinning the ends of it. Something not right there. I think I'll change that one out. Really funny how this power supply, I mean that must be at least the third resistor that's a bit dodgy. And it seems to be these ones that are in green for some reason so far anyway. That's curious. Okay, so I'll go away and change that out. Okay, that's the resistor changed out, so let's put power on and see what happens. Power on now, select the plus 25 volt rail and adjust the rotary encoder. Wow, look at that. 25 volt rail appears to be working now. All the way up to 25 and all the way down to 0. Yeah, so needed calibration, okay, but that's a step closer, and I'll just check the minus 25 volt rails okay. Yep, and it's fine as well. Okay, returning now to the ADC, I thought I'd turn my attention to try and find out why I don't seem to be getting any integration at all. So I'd already sorted out the reference, so I started following it through, and I'm looking at R5, R4 and R5, two 30k resistors, which basically tie in through this analog switch into the integrator op amp circuitry. So it's just part of the circuitry. So let's look at R4 and R5 on the main board. So that's R4 and R5 there. Couple of green resistors. Wow, what are we going to find here? So let me just zoom out so I can get the multimeter on short as well. And if I just go across R5, they are a little bit dirty. There's 12 mega ohms on R5. And R4, it's got about the same. It's really weird. And I've tried sort of scraping on the top surface of the resistors. But, you know, 13.4 mega ohms. 12.13 mega ohms. Those two resistors are faulty. Now they should be precision as well, I think. So I think these green resistors are probably all meant to be precision resistors. So we'll have to review that at the end. So let me go and change out those two resistors anyway for a couple of 30Ks. And we'll see where we go from there. So I've got both resistors off here, just sitting on top of my masking tape here. Let's go on to them. Open circuit. Open circuit as well. Wow. Okay, I'll go and change them out. Well, we are getting closer, because now I've got minus 28.14 on both the positive and the negative 25 volt rails. It's a little bit weird. The outputs are still working. I've got the flukes off camera there, and they are working. But if I just adjust the voltage up and down, I'm really getting nothing changing on the display there. I'll try selecting a different digit, and nothing seems to happen. Okay, I've been doing a little bit of probing off camera, and this is the D to A. So you've got the demultiplexer here, which produces all the individual analog voltages. For instance, the plus 25 volt voltage reference, the current reference, and the minus 25 volt voltage reference, current reference, and then the 6 volt voltage reference and the 6 volt constant current reference. So I went down them all, making sure they're all working, and they are, bar this one here. The 6 volt one just doing nothing. The 6 volt one's slightly different in that it's got 2 op amps. I'm getting a nice change in 0.1 to 2 volt varying voltage here when I adjust the front panel rotary encoder, but I'm getting nothing on here. Now, given that this one's at 0 volts, you've effectively got R126 is basically tied down to ground, really. And therefore, with this setup in place, I should be getting something varying here, but I'm not. So I went and looked at pins 9 and 10, and I measured the voltage on each of those there. Now, it's an op amp, so they should be almost identical voltage on both of them. Well, they weren't. They were volts apart. Now that's there's no shorts in the board. The resistors are all intact and the right resistances, no problem there. So I just concluded that the op amp was faulty. So I basically replaced U10, and it's working now. I'm now getting a varying signal here when I adjust the rotary encoder on the 6 volt channel. So let me show you on the front panel of the power supply where we're at now. So I'm on the 6 volt channel there, so the multimeter over there is reading 0.27. It's now reading something. And also the display is reading something as well, 0.248. And if I adjust the 6 volt channel, I'm now getting it working here, 0.8, 0.8. And I can basically go all the way up. So now 3.5, 3.6. Needs recalibrated slightly, but it's not too bad. So let's go into the minus 25 volt channel now. So I've got just under 0 volts there, and I've got just under 0 volts there. I'll adjust it up. Minus 0.9, minus 0.9. I'm now getting it. The power supply is doing what it's supposed to be doing. And all the way up to minus 25. I've got minus 25 there. Onto the plus 25 volt channel. It's still working on the output, as you can see, but I'm still getting 0 on the display there. So there's something still wrong with the plus 25 volt channel. It's permanently at 0 on the display. But we're getting closer. So here's the ADC. Now, I think I mentioned it earlier, there's actually a voltage divider basically on the bananas of the 3 channels, and they feed back the output voltage back into the ADC, and you can see the 25 volt ones coming in here. Now, monitoring the plus 25 volt VMON input, it's basically stuck at 0 volts all the time. The other ones are working. I can vary the rotary encoder on that channel and I'll see these varying nice and steady up and down, no problem. But the plus 25 volt VMON is stuck at more or less 0 volts. Now, I've checked the resistors on the voltage divider and they're perfect. There's nothing wrong there. So I started to think, well, maybe this chip here's faulty and it's grounding it or something internally. And the problem was this 261k resistor. It's intermittent from going open circuit to 261k. So I basically dumped it, put a new one on, and I'm now getting a varying voltage coming out of this voltage divider on the positive 25 volt rail. So let's go back to the front panel now and see how it's performing. So there we go, I'm on the positive 25 volt rail now, and now when I adjust it up, 8.19 volts, 8.21, it's now working. I'll just retry the 6 volt channel. 0.7, 0.7, yeah, and the minus 25 volt channel. Minus 5.13, minus 5.16. Looks like it's working. So the next thing to test is the current display, and let's see if it's working. So I've got my electronic dummy load hooked up off camera, and if we just I'll set it up to 1 amp, which I have got at the moment, and I'll go into the 6 volt channel and I'll put it to something like, let's put it 5 volts and try that. So switch on the dummy load, and we've got 1 amp on the display there. Perfect. Let's try one of the other channels. We'll try the positive 25 volt rail. I'll put it up to 5.25 volts and switch it on off camera. Yep, 0.998, that's working as well. And now the minus 25 volt rail. Let's set it 5.15 and switch it on. Yep, 0.985. Wow, it's great, it's working. So it looks like the power supply is working. I mean, I've still got to check out the constant current mode, but I've got no doubt that's working. I did scope the op amp that drives the constant current, constant voltage logic, and it's switching okay. There doesn't seem to be a problem there. And I still have to change out some of the resistors for precision resistors that I just temporarily changed during the repair process. But it looks like the power supply is working. There's a fan at the back. It's a little bit noisy. And I don't trust the bearing inside of it. Sometimes it's quiet, sometimes it makes a little bit of a noise. So I might actually just change out the fan. I've got a few fans lying around, and yeah, they're just a 12 volt fan that's in there, so there should be no problem there. The only other thing I've got to do is do a little bit of calibration, which I'll do again off camera, and I think that's it. The rotary encoder knob, I have got one on order. I found one on eBay, so I'm just waiting on that one arriving. It'll be the new year now before it probably arrives. The bottom board, the main power board in the bottom, I haven't actually touched. I never needed to go in there at all. There's some of the 6 volt power circuitry is down inside there. I never needed to go near it. All my faults were on the top board here. So I think I really enjoyed this repair. It's the kind of repair I like, where you really have to get your hands dirty and get into the schematics and do a lot of troubleshooting, a lot of testing, a lot of setup with multiple multimeters and oscilloscope and that sort of thing. So I really enjoyed it. So I hope I can find more like this. So anyway, here's to the next one. Thanks for watching.